Hello, hello. Um, the last couple of days I've been spending creating some modules, turbo modules to be specific, and this stuff is always changing. So I thought maybe it would be a good idea to make a new video about creating a C++ turbo module, a bit more modern this time. Only compatible with the new architecture because maybe you have heard with React Native 76, the new Arch is going to be turned on by default, so the migration is really happening this time. So I spent a little bit of time yesterday configuring a new C++ Turbo module. Very useful information. So I'm going to start by just creating a new module using React Builder Bob, React Native Builder Bob. It has now a uh, let's call this um no wait, let's call this so React Native Quack description. Okay, Quack. Yes, my email. Yes. Yes, doesn't matter. So here I'm going to select Turbo module, which will require the new architecture, and I'm going to do C++, and I'm going to use the vanilla app. Now, this is going to create a Turbo module for you, like all of it, and we could stop here and call it a day. But what we actually want is to create, so this will create a Turbo module that is a C++ Turbo module, but it has a wrapper. Um, it has a Objective-C and a Kotlin wrapper, which works, of course, but the problem is that you have some duplication because you first have to create, or you first will write your turbo module spec, and then you will have to create the Objective-C function definition or Kotlin definition, and then you will call your C++ functions, which kind of defeats the purpose of turbo modules, right, of code generation. And I didn't quite like this. I just wanted a simple C++ turbo module. And I came across, what's this? CPP. I came across this module. No, one is bcrypt, sorry. Bcrypt, this one. This React Native bcrypt CPP, which is by Andy. And you could tell from the configuration that this was created with Builder Bob as well, because you have this create React Native library, and it also has the Builder Bob dependency. But the interesting thing here is that he loads the C++ classes directly. So all credits to him. I guess, I don't know, he came up with this. He knows a little bit more about how iOS works when loading modules. So we're going to modify our project a little bit so that it loads as directly as possible without going through um, this Objective-C bridge. So before we start, what I'm going to do is go into my, or just do a yarn install first. It's all of the dependencies. Okay, now that I have the dependencies, I will go into my example folder, and then I will do a pod install. And if you take a look into the pod file, you can see here the new Arch is enabled by default, which is what we want. So I will modify the code generation process in a little bit. For now, I just want to get the XC workspace generated so I can take a look at some of the scripts. Okay, so the dependencies have finished installing. I did a pod install as well. And now we need to talk a little bit about code generation. So Builder Bob has been getting a lot more powerful lately. Of course, they want to help you do your turbo module as fast as possible. So one of the changes that they're doing now is that they have this configuration file that helps you generate the code, as well as this output directory. This is not standard CodeGen, right? So if you were to create a CodeGen module from scratch, just using React Native, um, this wouldn't be recognized. This is not part of the configuration. But basically what they do is they just mess with the code generation step, and they just dump the files in a place where it's more useful, or where you can directly inspect which code has been generated. So if we go to the iOS folder and here on the generated, you can see this is the code generated code, and it's a lot easier than spelunking for commands and trying to figure out where the code generation step has dropped all the stuff. Um, so this is all very nice and dandy, but the problem is, or at least the problem that I have is that I use Mise. So Mise is a tool that allows me to have um, it allows me to have per folder um, installation of tools, right? So I can have one folder, I can use one version of Node and the other a different one, a version of Ruby, a version of Cargo or whatever. Um, and this kind of messes up with some of the scripts that I use on UI apps. So for example, on Xcode, if you go to edit your scheme, you go to build and then pre-actions. Here you can see there has been a npx bob build target code gen command has been added, which I guess every time you click on the build button is going to try to do a fresh code generation, so to say. And this works very nice if you are using the default tooling. This will just auto-generate the code gen. It will always be up to date. So you won't have compilation errors because you didn't regenerate your JSI spec, so to say. But unfortunately, this doesn't work for me, and getting this to work is just a pain in the ass. So I'm just going to leave this out for now. And then I'm going to do, let's just change my native module definition. So let's say I don't want to multiply, I want to say hello, right? So I will have my hello function. Here, also don't know why they changed this, but I don't really care. This gives no type, so I'm just going to export a function hello, and I'm going to return like quack, right? And on my main app, again, I'm just going to use quack. Um, sorry, hello, and I'm just going to say hello. So in order to regenerate the code definition, I need to do a pod install every time, right? And here you will be able to see build and target CodeGen. This is part of BuilderPop. So once we have that, everything's being generated. And if you go to Xcode, you go to pods, development pods, and then let's search for the React Native Quack package. React Native Quack. Good. So here you will see these are the files that have been auto-generated by BuilderBob. And this is what I meant. Your C++ turbo module is being wrapped into a Objective-C turbo module, and probably a Kotlin turbo module. I haven't taken a look into that yet. Which is fine, but it kind of gives you this indirection where you first have to implement your Objective-C function before you can actually call your C++ function, right? So here you can see the definition is like, okay, if you have the new arch enabled, we're going to follow your generated code, you generate a class definition, so you have to implement this function, and then you make the jump towards C++, right? So here we're importing the Quack multiply function, which comes from React Native Quack from the actual C++ code. This is, like I said, it works, but not exactly what we want. So in order to make this work, we are going to get rid of these two classes. I can also do it in Xcode, but I prefer to do it here because I need to create a new file. And here I'm going to do onload right? So again, I guess this technique was discovered or developed by somebody who knows better how iOS works. So basically what I'm going to do here, and maybe this is going to take some time to debug because naming is a little bit confusing. I'm going to do again a yarn pods, a pod install. This is going to get rid of the old files in Xcode and should now drop the onload. Oh, sorry. Let me change the name because probably it's case sensitive. Not 100% sure. Okay, good. So if I now go to Xcode, I should have the onload class. I'm just going to drop here the contents of my of the definition of the package, and I'm going to change this to native. Let's see. Okay, so this should be native Quack turbo module, I guess. Oh no, we can replace this with React native Quack.h. Okay, so here we're going to find a little bit of trouble where we need to replace our class definition before we move on. So on the header file, I need to create a class instance because basically that's what we're doing here on load, right? We're saying register a C++ module to the global module map, and we need to pass an instance of, a turbo module. And in order to create a turbo module, we need to create our class definition in a way that implements the interface. So I'm just going to go to the class definition here, and I'm going to take this, and I'm going to just drop it here. And we'll go part by part why this doesn't work. So we're going to start with replacing. So this is a card for Android, but we only care about iOS for now. So we're going to do quack spec.jsi, right? So this is a generated class from JSI, which is right now not working because Xcode doesn't know. The bcrypt headers we don't need for now. And I'm going to change this class to, instead of native bcrypt blah, 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 turbo module, this is going to be my Quack turbo module. And I'm going to change this to Quack CXXX spec, right? So this is my class, and this is supposed to be a generated, the generated turbo module code. So if we go back to our generated code, if we go here and you take a look into the earn quack spec.jz.h, here you can see native quack spec. And it's basically saying, there's a little bit of indirection, but here you can see it needs to have a hello method that takes the runtime. It does some assertion to make sure everything, all the parameters are correct, and then it just tries to call it. So basically, this is the class that we need to extend, right? The native Quaxi XX spec. Good. So our class is going to need a constructor that's going to take a JS called invoker. We will take care of that later. And we need, of course, our hello function, right, which will take our runtime of class RT, of reference RT, and it returns a JSI value. The rest, I don't care too much about right now. Good. So we need to implement that class. Again, I'm just going to copy and paste because once you have it set it up, the rest is easy peasy. So I have my react quack. We don't need the thread yet. We're going to take a look into it in a little bit. But I'm just going to register in the correct namespace, which is the Facebook React namespace. And I am going to need the constructor, which is, yeah, and then it takes, I'm just going to copy this because it takes the JS invoker. Again, we're going to change this into the my base class, takes the type, which is a Quark Turbo module, and then it just moves the stuff. Did I create the constructor wrong? Turbo module, native Quark CSX spec. Okay, we'll figure it out in a little bit. For now, let's just create our hello function, which takes a JSI runtime reference, and we're going to return null for now. I think I am missing. I need the namespace JSI, which is Facebook JSI. Does that work? Yeah, okay. I think I know the problem. This header is wrong, so okay, now it works. So we were missing the correct header here, and then for this one, yeah, now it works, right? Everything is correct. Let me just open this on VS Code because it gives me nice indentation, automatic indentation. Okay, so if we try to build this now, let's see if it works. It shouldn't work, but we'll see. Oh yeah, so my onload class is definitely wrong. So I need my native Quark turbo module class. And here as well. Okay, now I got those two fixed. Let me fix that. Last one. Okay, it's nicer. It at some point updates, of course, because it's not updating. Okay, so I made a little mistake, which is if you take a look into the CXX spec, you can see that the method is defined as a JSI. It returns a JSI string and not a JSI value, right? So here, this method definition is to return a string, and here as well, this was returned in undefined. So I changed the type and I changed the type of the function and the return value. And now when I try to compile it, that gets rid of that error, but now we get a different error, right? So it's saying I cannot find turbo module hello. Well, it cannot find the spec.jsi. And here is what I'm guessing is some sort of incompatibility between how this module is being loaded and where the classes are being inspected and builder-bot. So in order to fix this, I'm just going to go here and I'm going to delete where the iOS generated classes are generated. and I'm going to do a pod install. We'll see. This folder shouldn't be used anymore. I'm going to do a clean, and I'm going to try to build it again. I forgot there's one other property we need to delete, which is this includes generated code. Again, I don't think this is part of the official code gen spec, but rather builder pop. So here you might see, sometimes you might get an error regarding Android, but it should be fine for now. And now if we try to compile it again, um, we're almost done. I forgot to add the class prefix so that it can find the symbol. Nice, it finally succeeded. So let's see if it starts. Come on. So, hello world, nice. Good. So I'm sorry about the compilation errors. Again, this is a kind of hit and miss process, but you will see this pretty much what you need to do. So here I'm going to replace this one with the generated spec for our module. Again, this React CodeGen preposition, that's for Android, I guess. Uh, on iOS, the classes just get dropped in a different package and whatnot. Um, there's one more thing that I would like to show you, which is how to do promises on the C++ Turbo module. So if you have seen the previous videos, you know that the JS invoker is what allows you to schedule a callback if you're working on a different thread, right? So you cannot, if you spawn a thread, you cannot just directly talk to the JS machine. It will mess with it. It will corrupt itself. You will mess with the memory. So we need to schedule callbacks into the React Native or into the JavaScript thread. So I'm going to include thread, which will allow me to create a thread very easily. I am going to change this definition. I'm going to return a promise. Again, I'm going to do a pod install. So the code generation happens again, but it shouldn't really matter because let's just wait for it to finish. So now if you go to, if we take a look into our CXX spec, nothing has changed. Well, it has changed to a JSI value, right? So we are not returning the string directly anymore, but we need to return a promise. So how do we do this? I'm going to change my definition, my method definition. I am also going to bring a file that I always use, which is very useful for this stuff. It's called macros.h. And on my macros.h, I just have a template for a host function. I'm going to do a pod install again, so the file gets dropped in the correct place for, or gets recognized by Xcode. I'm going to include my macros.h. It's not there yet, maybe, who knows? Okay, and here we need, let me just copy some stuff because it will be easier that way. So we need to create a promise and then return that promise into the calling JavaScript function, right? So what I'm going to do is I'm going to reach into the global object and I'm going to get the promise. And I'm just going to call that promise as a constructor. And yeah, I think that should work. Right, so I'm basically just constructing a promise and just returning it into the, um, let's see, why is it out of the load to runtime or to value? Okay, doesn't matter. Let's continue for now and then we'll see how far we get along. So I'm calling the promise as a constructor that returns me a promise object. So this is what I'm going to return to the calling context, but the constructor takes a function. So I'm using my macro, which just creates a host function. And I'm just casting the arguments. The first argument as the resolve object, and the second one's the reject object. And once I'm here, I am going to create a thread. So this is probably not the most efficient way because it might be creating the thread right from like on each invocation might start a new thread. What you probably want is a thread pool, but I'm still not 100% sure if this is what you want or not. This is also kind of a new way of invoking threads for me, so we'll have to figure it out. Okay, so the thread takes a lambda, and I'm just going to detach the thread so it doesn't block, right? And inside of the lambda, I'm just going to pretend some computation has happened. But for now, I just create a string. And once I have the result of my computation, then what I need to do is uh, reach into my invoker, and I'm going to say invoke async. And the invoke async method, again, takes a lambda. So what I'm going to do here is I'm going to grab some of the references that I need, which will be the resolve. And I also need a reference to my hello string. And then inside here, I can now interact with the JSI with the runtime object again in a safe manner. Nothing will be corrupted. So I can just do string create from UTF-8. And I'm just going to pass my hello string. And then finally, what I'm going to do is I'm going to call my resolve, right? So we just first have to cast it into an object, and then as a function, and then I can finally say call with my hello string. Okay, let's see what's wrong in here. So I have previous declarations here. Okay, so first I need to update the return value of my header. And I am missing here, I'm missing my runtime. And because this is a lambda, or this needs, when you call a constructor with your promise function, it still needs to return. So when you're doing JSI, this is still needed. Okay, so I'm going to change that. And if I go here, this hello function should return a promise, which is good. And here you can see now we're trying to display a promise. So we're going to change this a little bit, and we're going to say, okay, result. I'm going to import from React, and then I have to use use effect thread so that it only runs when the component mounts, and then I'll say hello, and then set result. This should be string. Okay, so now it crashed, probably because trying to do stuff that it's not supposed to do. But let's compile it again and see what happens. Okay, so it is still crashing. Okay, so let's do some debugging, right? So it's saying it's capturing this. So it's failing when it tries to create from a UTF-8. It says it has a bad memory access. Okay, so probably okay, yeah. So here's an error, for example, right? This is lambdas, this is real C++, but basically what I'm saying to the lambda is just hold a reference to this string. But since this is invoked async, this function is going to resolve, and the memory of my string has probably been already deallocated by the time this starts executing. Right, so I'm just going to pass it here, and then what's going to do is just going to create a copy of the string that's going to live inside of the lambda. If I don't want to create copies because copies are expensive, then I need to use move semantics, right? I need to tell this, let's try it like this. Let's see if that works. So I'm basically telling you can safely move this value into this variable inside of the lambda. Right, so then I don't create any copies. I just move that value inside of the invoke async. And that's it. Again, sorry for the mistakes. Doing this fast, mostly as a note to myself. um, oh yeah, before I forget, if you are going to publish this CodeGen module, you need to, I just remove the exports because the CodeGen scripts, they crawl through your dependencies and they look for the package.json, and then they look for um, this key, right? And if you have this key, then it will auto-generate the classes. But for some reason, you now need to declare the export, you need to declare your package.json in here. It's a mess. You don't really need it, at least for now. I just delete the exports, and then you should be fine to publish your package however way you want. Okay, enjoy. Take care.